I am very excited to be doing brain theory, and this is with my boy, Dr. Jason McKeown. All right, kick us off. Who are you? Why you're here?
Yeah, thanks for having me.
Absolutely, dude.
So, yep, as you say, Jason McKeown, previously an ER physician, really, in the UK.
Don't you have to keep doing it to maintain your license or something?
Yeah, I still do. So my weekends are often spent in the ER.
Don't tell the people that you're operating on that you're previously an ER doctor. I think that may be somewhat nerve-wracking.
Yeah, so no, I still keep my hand in at that, but a couple of years ago I shifted over to neurology or neuroscience, as you know. Really interested in the brain in general, but in particular why we struggle with weight loss. So why can some people be...
Did you end up on weight loss like right away? Or was that something that came later?
No, pretty much. I mean, I had an interest, as I say, just was in general neurology. It's almost a stroke of good luck. The guy that I was working with, it was in neurosurgery at the time, had just finished his thesis on vestibular stimulation. And at that time, he was working with Rama, or V.S. Ramachandran, as your guys will know him. And they wanted to set up a new project. As part of his thesis, he realized there are ways to stimulate metabolism, which is obviously a pretty big thing.
All right, and we're going to get into detail in that in a little bit, so don't panic if these terms aren't very familiar. But yeah, I just want to finish with your overview first while I swab the back of my ears here.
I'm sure people are wondering what you do, but
what is happening?
So yeah, I mean, in a nutshell, the question that we wanted to answer was, can you find a practical, easy, safe, non-invasive way to stimulate the part of your brain that controls metabolism? So that was myself, Paul McGeown, and Rama, or V.S. Ramachandran, I should say. And we set up that team in San Diego a few years ago.
Well, before we go too deep in that, so walk me through, you're an ER guy with an interest in the brain. How do you make the transition? Do you go back to school? Do you apply to work with V.S. Ramachandran? Like, what's that story? How do you end up in San Diego?
Pretty much a phone call with Rama. So,
so was it you like, okay, I'm super interested in neuroscience and I know who the preeminent mind is?
My interest, I suppose, was just actually peripheral to all my other work. So just in the background, I was like reading and studying and just really getting deep into neuroscience and like, you know, thinking a lot about it. Obviously, anyone who's in that field knows who Rama is. I never, as I say, my colleague at that time, Paul, introduced me to Rama. I pretty much had one phone call. We chatted about my thoughts on it. They ran quite parallel to his. I had some interest in, I suppose, ideas about how you could use, like, you know, any type of stimulation, but in particular vestibular stimulation. So I think Rama just sort of thought there's a good fit here, so invited me out to be one of his visiting scholars.
The youngest visiting scholar ever to work with the legendary V.S. Ramachandran, who's been a guest on the show, and by the way, and I'm not kidding, like V.S. Rama, can I tell you, when he told me, call me Rama, I was like, really? Can I? I was like totally fanboying out hard on that one. He's the one that really taught me about the brain through his books. Obviously, I'd never met him, but his books are so accessible, and he's so funny and so interesting, and he's got such a way of making it all accessible that was desperate to get him on the show, and finally got him on. He was actually one of our first Impact Theory guests, but we'd been trying to get him on since we were inside Quest. So finally got him on, and that was really, really incredible. So being like, and I need to remember the list because he did the oh God, what's it called? The Gifford Lecture, and he did something else in the UK, and they're like these huge honors for the most famous minds in science. And some of the people that have done them, I mean, he's just in rarefied company.
Yeah, I mean, he's absolutely the greatest neuroscientist of our generation.
Yeah,
you know,
there's no question.
Just to even know him, but to actually sort of work under him is like it's a privilege.
Yeah, it was pretty cool when we did the whatever we're going to call that round table about what you're doing at Modius Health, and Dr. Drew was on the show. Now, Dr. Drew's wildly famous, like magnitudes more famous than Rama, and when introducing himself, he was like, I just have to say, like, I'm honored to be sharing the dais with, you know, the legendary V.S. Ramachandran. That was cool. That was when I was like, all right, that shows even though he's like this quiet, unassuming guy, the weight that he carries in that community. It's pretty
Yeah,
special.
no, it's cool. And even like we would have like a weekly sort of lab meeting with teaching and that, and it's just so chilled and laid back, and he talks and everybody listens, and it's just like, yeah, this is pretty cool.
Pretty amazing. All right, so you ring him up, and he says, come out to San Diego to be a part of this. Did you already know that you wanted to found this company?
I suppose a lot of things ran in parallel, but the idea was, primarily the idea was research. It sounds a bit maybe trite saying this all the time, but like I actually did get into medicine to help people, and then this idea of we could research one of such a fundamental problem. Like 2 billion people approximately are overweight, and it's a precursor to metabolic disease, diabetes, heart attacks, strokes. If you could actually influence that even like a tiny little bit, the knock-on effect of that is huge. It's potentially game-changing across the world. So just to research that was enough for me. But then actually, as we started to see the potential of it, and the spin out of, say, into the medical device sector or even into the consumer sector, then we're just really interested, I suppose, in protecting that and forming a company. So that's what Modius is really.
All right. So before we dive into that, what is it about the brain that fascinated you enough to switch from being an ER doctor to that?
It's a good question. The really candid answer is that actually, aside from the physical housing that is your nervous system, nothing else is real. So
what do you mean by that?
I'm sure that fits with the impact theory. You have a bunch of neurons that are effectively sort of electrochemical signals that are running up and down. But within that house, there is a thing which we refer to as consciousness. But aside from that, everything else is just a complete virtualization within that. So, as we sit here now looking at each other, there's not like, the picture of, I can see you in the microphone, there's not like a little picture that gets miniaturized and goes in, through my eye. And then, there's not like a little picture in the back of my brain somewhere that is actually this, okay? Right. This entire thing is just a chemical virtualization. So
your brain is basically making it all up.
Yeah. So as soon as the actual light hits my eye, that's it. That's where it stops. And then after that, it turns into electrical, chemical kind of signals that fire across neurons. And I have this illusion, for lack of a better word, that we're sitting here chatting. Obviously, we are, but what is happening inside is entirely fabricated by your own brain, and I find that just unbelievably amazing.
Dude, you and I are together on that. It's really interesting. You end up collecting people in life that see things the way that you see things, that are intrigued by the same things that you're intrigued by. And that was one of the fun things that kicked off when we were just hanging out the other day in the San Jose airport. Just like geeking out on this stuff and the fascination we have with that. The biggest breakthrough in my life, and the reason that this company exists, and the reason that we founded it the way that we did, and the reason that the Matrix sits at the core of all of it, was that realization that my brain is what I call lying to me. It's virtualizing it, right? It's doing its best when being totally encased in darkness to recreate this world. And once you realize that it has tendencies towards this, that, or the other, that, okay, this is all made up. There's no objective reality that I'm actually experiencing. I'm experiencing an interpretation of reality. So once I could say, okay, well, what happens if I insert my consciousness into that interpretation of reality? Can I nudge things in a more, what I'll call, effective direction, where I say, these are my goals, and now I'm going to, rather than just sit back and say, oh, this is all objectively real, I'm going to say, this isn't objectively real, and because it's not objective, I'm going to choose to believe certain things, and those beliefs now will give me a better outcome. Yeah,
Totally get it.
That is my shared fascination, my friend. Very interesting.
No, and the other thing, the potential for people, I suppose some people get sort of very low and in a rut, and you can convince yourself actually, like there is no potential. But actually, the big driver, big belief that I have is that with time and with the right attitude, you can change those things. But understanding, and this is probably why my interest grew, understanding why your brain tells you the things, and also why the physical housing, i.e. the neurons and the nervous system, develops in the way it does. Understanding that gives you the advantage to be able to then achieve the outcome that you want. So it's the actual knowledge allows you to be better, if that makes sense.
Definitely. When did you start getting obsessed with this? Like, you're cutting people open. That's pretty demanding. And this is something you and I talked about. I could never do what you do because you're dealing with people on their worst day. Like, coming into the ER, oh God, the way that it would overwhelm, the last thing I would want to do is go deeper into the medical world. So how did you begin thinking like, okay, this is more than a passing interest. I am deeply fascinated by this. Everything else is not real, in your words. Like, how did that grow into the fire that leads you to leave everything, to leave Northern Ireland, to come to Southern California, to change everything up, ultimately found a company? I mean, this is a huge shift that it's the kind of thing most people talk about, but they never do. And so you actually did it. So what allowed it to grow into that fire? I'm just going to adjust my Modius up here.
It's okay. Yeah, that's maybe a difficult question to pinpoint. I probably would draw back to when I just loved technology. So before I was into medicine, I was really into like computers and more sort of like kind of firmware and hardware to some degree.
Interesting.
So yeah, so probably when I was about 14, 15, I started like selling computers that I built. So I know now like everybody can sort of do that, but actually back at that time it wasn't that popular. So you know, I started literally selling people who I got the same bus to school with, and then in my class, and then in my year at school, and then in my town. Okay, wow. So I was like doing that, just building. So my room was just like piled high of like hard drives and motherboards and all sorts of stuff. But then I suppose there's a parallel with, you know, the body is a bit like a computer. I don't love that analogy, but, you know, your brain is a bit like a computer, and people can understand that. So I suppose it's gone to that next step. So moving away from, you know, very hard defined technology to, you know, well, is this, you know, a machine? Is your body a machine? Is it a computer? Can you influence this in this way? I think that was just the natural progression. But I still didn't lose my love of technology, and actually now things have come back. So I went from initially to technology, then to medicine, and now both together with neurostimulation.
All right. So now, what is this thing on my head? What's it supposedly doing? What is Modius Health?
So it's a neurostimulator. So, I mean, I'm not sure where to dive right into. I suppose...
We'll go back to what you were saying about weight loss. So
yeah, I was going to do a little bit of why it's difficult to lose weight.
Okay.
Because that is quite interesting, I think. And if this works, I should be able to let people see what I'm drawing on my screen.
Nice.
What an age to be alive.
Right? Yeah. And this is your A cam, by the way, if you're going to show something to the camera.
Let me see. I may need a password for the screen.
For the screen? Oh, you're going to, it's right there, 3923. Oh, yeah. So I guess you don't need your A camera. It's going to appear on the TV. All right, we're mirroring.
Right. Okay, so if I ramble, you can stop.
Yeah, I'll rein you in, don't worry.
I mean, the problem is that people struggle with weight loss, okay, but typically don't struggle with weight gain. Yeah.
Yeah.
Right.
That is certainly my case. Yeah. And I know some people do.
Well, yeah.
As much as I want to laugh at them.
It's quite interesting because actually some people do struggle with weight gain. A good example of this is, I think it's 1967. I mean, this is so unethical. It is unbelievable. But they give prisoners a reduced sentence for trying to increase their body fat by 25%.
You think that's unethical?
It's crazy. I mean, you can.
Why?
Well, you can't manipulate prisoners to do things, you know.
It's just because. Sorry, I'm just thinking of the experiment. You think it's bad because it's prisoners?
Oh, absolutely.
What if it were like me and I wanted just some cash to try it?
I think it actually was tried in medical students first, but nobody could do it. So they went to prisoners because they thought, well, they would do it. But as I say, that's completely unethical. That would never be allowed today.
Really? This was in 77?
67.
67.
But it did happen, and basically the target was 25% increase in your body fat, eat as much as you want. So typically they ate around 10,000 calories a day.
Wow.
Okay.
That actually gets hard to sustain.
Okay. The actual problem was they couldn't hit the target. They couldn't gain
the caloric target. Yeah. You just feel so gross.
The weight gain target.
Okay.
So they did gain weight, but not as much as you think. And actually, whenever they then went back to normal eating, they lost the weight really, really quickly. Okay, bar I think 2 people who actually didn't lose any weight at all. So the question, and then also whenever they started this experiment, whenever they ramped up the calories, their metabolism went like into overdrive to try.
What are they using to measure that?
I tried to work that out. Actually, I'm not sure. So you can read the paper, but basically there was this massive reaction to those guys trying to actively gain weight. Okay, so the theory around this is, and it's pretty well defined, there is actually a range of a sort of target weight that your body wants you to have. Okay, so I'm going to just say, like, so let's say, can you see this? Yeah. Yep. So let's say, for example, your weight's like 170 pounds, okay? And this is you kind of going through your life. Your weight isn't actually always 170 pounds. It tends to sort of go, up and down like that without you having to think much about it.
Right.
Okay. And that's entirely normal. So what we call the set point is actually sort of the low and the high range, say, of, it's getting very colorful now, isn't it? So this sort of range is your set point. And in a normal weight person, that's maybe like, let's say 165 to 175 pounds. But without you thinking about it, your body will keep you there, or it should do. Okay. Now, the problem is the lower end. So sorry, I should say other things. A lot of people don't realize that the mechanisms to increase weight and decrease weight are not just sort of one thing. There's actually an active process that your body kicks in to decrease body fat. There's also an active process to increase body fat, and those two are actually separate. It's not just the sort of lack of the other one. Okay, and this is actually, we were chatting about kind of negative feedback before. Yeah. You don't love that term.
Well, now I use it all the time. Like, this was a really powerful idea that you gave about the seesaw effect.
Yeah. So a good way to understand negative feedback is basically it's like a seesaw. So it's a balancing act. So let's say the balance is 170. The seesaw kind of roughly goes around kind of 165 to 175.
And I know this isn't perfect, but one of the ways that I've been explaining it to people, and that I explain it in my own mind, is if you think of the sympathetic nervous system and the parasympathetic nervous system. So sympathetic nervous system, fight or flight. Parasympathetic, rest and digest, that you're not going to have them both elevated at the same time. I know you said it is possible, but that's very, very rare. And that typically when you do something like a meditative practice where you're slowing your breathing, slowing your heart rate, bringing your mind back to just the centered breathing so that you're not kicking in stress or anxiety, that you get as the parasympathetic kicks in, the sympathetic drops down, which is why meditating lowers your stress, lowers your anxiety, because it's hard to peg them both at the same time. So that gave me a really clear sense of this. Just like if something freaks me out and my anxiety spikes, the parasympathetic nervous system is disengaged and drops down, and the sympathetic nervous system kicks off.
Yeah, so that's a really good example, and that is so those are two separate processes, if you understand. A lot of people think that it's just one goes up and then it comes back down to the normal.
It's the same system.
Yeah, but it's not. It's actually one is inhibitory and one is activating. Okay, so you have these processes for your body fat. So sorry, ignore my really horrible drawings, by the way.
What they lack in beauty, they make up in being clear. How about that?
Yeah, okay. So the problem is this. One of those mechanisms has been tested forever and one hasn't. Okay, so ask yourself this. In the past...
And when you say that, the mechanism for gaining weight and the mechanism for losing weight, one of those has been tested.
Yeah. So, ask yourself this question. In the past... the entire human species, have we more likely to have died, basically, because we had so much food that we have eaten ourselves to death, or that we have had so little food that you were going to starve? Okay, so
I remember where I was sitting when you said that to me. That was when we were at the bus stop. Yeah. And that's how hard it hit me. It like permanently imprinted where I was. That is... Yeah, that was one of those really cool realizations that you're right. Nature has tested, for however many hundreds of thousands of years and however many permutations, our ability to survive famine.
Yeah. So keep in mind, as I say, there are two processes. So it's not just a kind of so the term we would use is homeostasis for, you know, like kind of that sort of seesaw. We call that homeostasis. Okay, so the entire process of homeostasis has not been tested. It is only the one that stops you losing too much body fat. Okay, so your body is a machine. It is almost perfect at stopping you losing fat. Okay, so in that sort
because it's a survival mechanism.
yeah, because if you didn't have that, you would have died, and that's, you know, your genetic sort of predisposition to actually surviving no food would have been wiped out.
Right.
Okay. On the other hand, the mechanism for protecting you against overeating has literally never in the history of humankind, it has never been tested. Okay.
So there's never before been a period like this
Well,
where you can go around the corner, dirt cheap,
Yeah.
buy anything and everything you want, eat your 10,000 calories a day.
Not that I'm aware of.
Yeah, right.
So in human history, that has never happened, okay? So basically, it has left us to be exceptionally finely tuned at not losing fat and not so great at actually not becoming too overweight,
Right.
storing too much fat, okay? And yet so getting back to where we were, the science behind this is really, really interesting. And I was actually going to talk a little bit about the areas in the hypothalamus, if you want, which...
Yeah, please walk people through, though, just the simplified version of why the hypothalamus matters, how it ties to vestibular stimulation, like what am I doing right now, right? So I'm zapping my vestibular nerve,
Yes.
which...
So I'm going to just take a little step back. So
Okay.
the as I say, there's that sort of seesaw, okay? So for weight going up or weight going down, okay? It's very specific actually to body fat, so adipose tissue. So your fat storage goes up or fat storage goes down, but it sits around, as I say, the diagram is kind of the sort of central point, okay? That central point is determined, that is set by an area in your brain called your hypothalamus. And it's a protective mechanism. It's meant to protect you, as I say, from being either too lean or too overweight. So the problem then is that the hypothalamus, with, you know, certainly with age, with diet, with high calories, you know, even some sort of high fat diets, high sugar diets, and our sort of Western sedentary lifestyles, that hypothalamic control, a bit like a thermostat, actually goes up. Okay, so it's like dialing up the level for fat. So all of a sudden, the balance, that sort of seesaw, it's still doing the seesaw, but the whole seesaw has actually shifted and is now much higher.
Right,
Than
so you're
it
taking
should
that
be.
band and you're moving it up.
Yeah, so like, I mean, this is really poor drawings, I know, but, you know, say that you're sort of, you know, oh goodness, I'm drawing over busy. That's right. Sorry, 2 seconds. You know, so say here's your 170 pounds, okay, and you're doing this, you know, you're sort of up and down, up and down, up and down, okay. You know, as you actually, what is actually happening in today's society is, yes, you're doing this up and down, but it's actually doing this up and down, okay. And then your new sort of set point is like, you know, 185, say, okay. So your autonomic control, your homeostasis still works, but you've shifted everything. Your metabolism has actually shifted entirely to someone who has naturally now more body fat. That shift is controlled by an area called your hypothalamus. And that is the absolute key to all of this. So the people who are trying to lose weight, the absolute key to this is their hypothalamus. Okay? So what we are doing is actually trying to influence the hypothalamus, and that's what we set out with, you know, Paul and Ram and I, that can you modify the hypothalamus and if not push it right down, certainly make it easier to try and get it back down again.
Okay. So if it isn't just pushing it down, how would it facilitate making it easier? What do you mean easier? That through diet, lifestyle changes, exercise, that you can bring it back down?
Yeah, so I mean, this is where possibly it gets a little deep, but I can start talking about the hypothalamus now. It depends how deep you want the science to go.
So thankfully, I've, you know, not too long ago been a total outsider to this whole concept. And what really made it make sense to me is there's no calorie counter in the body. So once you know there's nothing in the body, as far as we know, that counts the calories. That's, checking your stomach, checking your digestive tract and going, okay, this is this many calories. And so, and tracking how active you've been from a caloric standpoint. So going, okay, we took in this many and we used up this many. And so, you know what? Every day I'm noticing that we have a surplus. There is nothing for that. So once we know that the whole notion of a calorie was invented by us to be able to track sort of what the heat energy potential there is in food, which is great. It gives us a consistent measurement, but it doesn't actually correlate to the way that the body responds to food. Okay, so that's fact number one that you need to know. The second thing is what the body does seem to be able to track is motion. And what the body uses to track motion is the inner ear, the vestibular system. So if you are moving a lot, your hypothesis goes, and I love this because it's one of those that like, God, you can follow the logic all the way to understand why your hypothesis about the device is what it is. So if the body can't track calories, but it can track motion, and that it has sort of a pre-programmed assumption that if I'm very active, I'm moving a lot, then storing a lot of fat tissue actually is disadvantageous because I need to be mobile and lithe. So think of a lion or a cheetah, they're always shredded. They're always shredded, right? Because they have to be able to do these like lots of running, sprinting, whatever to catch it. So carrying a lot of fat would be dangerous from the perspective of it needs to hunt and kill, and it would be slowed down by carrying all that weight. Okay, so now you've got this system that tracks motion to know whether it should be storing fat or not. And so if this body is at motion a lot, then the hypothalamus says, okay, cool, we need to lower the amount of body fat that we store, potentially by raising the metabolic rate, the rate at which it oxidizes fat. So if that's just cranking it up and you're kicking off heat energy, so like my wife and I have a cheat weekend, my body temperature does not change and I get fat. My wife, on the other hand, will sweat through the sheets when she cheats because her body goes, whoa, like there's been no change in the movement. And here I am, I'm, taking, somebody euthanized that lovely dog of mine. I'm taking in this, excessive amount, and it's interesting to think because I don't know what that mechanism, like how is it knowing that I've upregulated my calories because there's nothing counting it? So what exactly, honestly, I have no idea. You'll have to help us there. But so it literally turns up her heat so that she kicks it off as heat energy rather than storing it as adipose. Now what that tells me is that she obviously has a lower set point than I do to store body fat, whereas I'm constantly living below mine. So when I give it the additional food, that rather than burning it off, it says, oh, finally, right? Like I can actually get back to my set point. So that's how I've thought about why the vestibular system, which tracks motion, would be involved. Because what this is doing is zapping my vestibular nerve to essentially mimic motion to tell my body he's very active. So there's no reason to store the extra fat. Yeah,
well, so there's a few things for what you said there. So there have been studies done that look at calorie consumption for someone, let's pick a weight, okay, 130 pounds. So if you're 130 pounds and you've never been above 130 pounds, you can eat more calories than someone who has been overweight and is now back to 130 pounds.
That's interesting. Because you've trained the body to store that fat, or?
Well, it's probably the set point of the person who was overweight still wants them to get back there.
I see. So it just hasn't changed.
Yeah, so naturally someone who's, say, a natural, lean kind of physique is going to actually just burn through calories, and their body reacts really, really quickly to that, and they find it difficult. We all know those people to gain weight.
Yeah.
Whereas someone who's been overweight and has slimmed down and is now leaner is constantly, potentially for years, fighting against that desire their brain has to gain that weight back. Their brain constantly thinks they're underweight now.
Because they've never readjusted the set point. All right, I'm going to press you a bit on why the body reacts so slowly. But first, I want to announce that we have our giveaway question. So we're going to be giving away one of these devices to somebody out there. And this thing is intriguing. I'll give you my official read on where I think this is headed later in the episode. But for now, our question is, who is one of the famous neuroscientists that has authored a book on my reading list and been on Impact Theory as a guest? And if you've made it this far in the episode and you have not figured that answer out, then we've really got some trouble. And if you're just joining us, thank you for joining us. This is a 24-hour live that we're doing because we crossed 100,000 likes on Facebook, and I really wanted to do something to be of service to you guys. So we're doing a live for a full 24 hours, uninterrupted, answering questions. So by the way, if you have any questions pertaining to Dr. Jason McKeown, please do post them, and we'll be answering them during the segment. And yeah, really wanted to do something where I was here showing you guys how grateful I am for everything that you've done to help build this community. And by the way, if this is adding value, please do share it right now. Go to your Facebook, share button, click that. Let people know that in the middle of the night, here we are rocking it, adding value. All right, so this current giveaway is for US only. I think Dr. McKeown can do better than that. Do we have international devices that we can ship? All right, boom, this one at least is good in the US and Europe. How about that? We'll extend that one to European customers as well. All right, so here we go. Oh, we have a fan question. Let's get one, we'll hold off unless it pertains to this. Let's stick to the vibe. All right, you were about to, in fact, I was about to press you. So why would this change the set point so rapidly when just normally having dieted down and held it, for 6 months or even a year may not reset it?
Good question. Do you want me just to draw? Can I draw some
Sure.
stuff like my
Yeah,
drawing?
please.
I just bought this app for the iPad.
You're like, I want to use it, damn it.
Yeah. So we'll talk a little bit about the hypothalamus, and there are several nuclei in the hypothalamus that we know. I mean, we absolutely know for a fact that they cause changes in metabolism, be it that it drives your appetite up or down, or it just causes you to store fat. Okay, regardless of calories.
Is this something we've learned through like damaged brain patients, where somebody takes damage to the hypothalamus, and what happens?
Yeah, so you can actually see this. I mean, you can force, it sounds horrendous, like you can put lesions in the hypothalamus literally with a knife, mice or whatever, and depending on where you put it, I mean, they just explode with obesity.
Really?
Or they get really, really lean. So you can actually change it, and you can...
Can you pick the lesion that makes them obese or makes them lean?
Yeah.
Really?
Yeah.
Whoa.
Yeah, so...
Is it like areas of the hypothalamus?
Yeah, so there's three main areas. There's I'll talk about you
going to draw them for us?
I will draw the main one. So there's, the overriding one really that we think is one called the melanocortical system, which is effectively the arcuate nucleus of the hypothalamus.
The arcuate?
Yeah.
That's a word?
Yeah.
What does that mean?
It's just the name of that nucleus.
Okay.
So I'm going to split it again. So we like our seesaws, okay? So there's going to be one side of it. We're going to call this side, let me see. So this increases sort of fat. Okay, so the goal there is to increase fat.
And is this sort of a rough ballpark of what the hypothalamus actually looks like? Because I actually don't know what the hypothalamus looks like.
Well, this is just this specific neuron
or
area, really. Okay, so let's say that. So this nucleus really gets information. So basically the hypothalamus is just a control center. So it takes feedback, it makes a decision to some degree, and then it adjusts the outflow. So the autonomic outflow, adjusts that into the body. So it'll register everything coming out of the body, make a decision, kind of the seesaw. So it'll say, oh, the seesaw's a little unbalanced. I'm going to do this to try and balance it again. Okay. So this nucleus really, it either activates or inhibits fat storage, right? But so so this is called your POMC. Sorry, this is very technical. And this one is called your AGRP, or the neuropeptide Y. And these are just neurons in the part of the brain, okay? And as I say, you want to, this is for decreasing sort of fat, okay? So we want to decrease fat. So the idea is that you always want to, for people who are overweight, okay, you want to try and stimulate the POMC side, okay. Now you may have heard of these two things, but there are two hormones that do this very, very well. One is insulin, and one is leptin. I apologize about how bad the leptin. Sorry. So I mean, a lot of people are going to say, hold on. So you're telling me insulin decreases fat. And that is what I'm saying.
Which is very counterintuitive, because here's how I used to think of insulin, that it's what pulls glucose out of the bloodstream and puts it into adipose tissue.
Yeah, that's exactly right. But a parallel signal to the central nervous system is that you've had enough. So if you think about that, that's a really...
That you've eaten enough.
Yeah, so that's a really perfect almost setup, because one chemical drives both. So insulin drives the nutrients into your body because you've just had a meal, and at the same time it lets your nervous system know that you've just had a meal, so it will stop you overeating. Okay, and leptin is the same. It's secreted by fat cells basically. So if you have a meal or whatever, and there's fat cells are full, they release leptin. Okay, so these are two really powerful hormones that hit this part of the hypothalamus and tell your body to stop eating. Okay, or decrease fat or whatever. The problem is that both of these hormones, both of them, are really susceptible to actually being overproduced, and then you desensitize. Okay, so you've heard of insulin resistance,
yeah,
right? Which is a massive factor in type 2 diabetes. So what happens is the insulin actually increases and increases and increases, but the hypothalamus has desensitized so much it never gets the signal to say you're full. Now, insulin's like massively anabolic. So ask any of the sort of big bodybuilders. They know this, okay?
Right.
Insulin's massively anabolic. So all of a
Meaning
sudden...
it helps you add muscle.
Yeah, or just adds mass, really. So it's fine if you're lifting weights, because it'll go to muscle. But actually what happens is you're now swimming in, a soup of anabolic hormones, but your brain never gets the signal to stop eating. Okay? So the problem is then, I'm going to jump over to the other side. So that is one side, that is one pathway, that is the decreased fat pathway. Then the other pathway is to increase fat, and there's a hormone, you may have heard of it, called ghrelin. Okay, now ghrelin is secreted by the stomach when it's hungry. That's what gives you the sort of hunger pangs. Okay, so let's say you're now overweight, so you have just wiped out this side. Whoops, sorry, you've just sort of wiped out this side. Okay, so all you have left is signals saying that you're perpetually hungry. You get no signals to say that actually I've had enough.
Well, you get the signals, you're awash in the signals, but you can't hear them. Yeah. Right? Because the cells now have become resistant.
Yeah.
It's very interesting. Really fast before we go any farther, we have a fan question here from Gabriel Deliberali. What is the most fascinating thing about the brain that you would like the world to know? And what is the frontier of knowledge on consciousness? Remember, you brought that up. What do we actually know about it? And then we'll go back to Ghrelin once you answer this question.
Probably the most fascinating thing is our lack of knowledge on consciousness. So I'm sort of answering both questions at once there.
Why do you think it's so hard to pin down?
A question that I would often ask people is say I could lift out one neuron at a time, or make an electronic sort of neuron, and I replicated your brain in its entirety perfectly with electronic neurons, it would function like your brain, but would it have consciousness?
That's the question.
Yeah, so if you say no, well then hold on. So if you have a one-to-one copy, why would it not have consciousness? And also at some point, if I started stripping neurons out of my brain one by one, at some point, is there one sort of click over moment where you lose consciousness? That's really interesting. Yeah, and if that's the case and you put that one back in, would it bring you back again? So it's just... That's interesting. And I don't find debates about consciousness very fascinating, I'll be really honest with you. But asking that question, like if you're stripping it one neuron at a time, like where is that breakover point? Here's what's interesting. I think at first you would start to just deteriorate, right? It would be a scale. It's not going to be binary. Like somebody with... advanced Alzheimer's. At what point are they a machine running a program, and at what point are they truly conscious, right? Because I think, have you ever been deeply confused? It's a very surreal experience, right? Where the deep confusion has given me that sense of what I bet Alzheimer's is really like, where it's like, fuck, I now feel like a conglomerate of algorithms,
but it's not quite adding up. Like it's a pretty weird and scary sensation. So my gut is it'd be something like that. That you would just grow increasingly confused until to a person interacting with you, you would no longer seem coherent. Yeah. And somewhere in there, you'd sort of be coming in and out of what we would call consciousness.
Yeah. Yeah, the in and out part is interesting. So, because a lot of people with, just to take Alzheimer's for an example, would have, lucid moments. So where they actually kind of appear to come back up again. So what were they not? Did they not have consciousness?
Right.
And then all of a sudden they have it, and then it goes. It's.
I literally think that's almost exactly what's happening because you get into a firing pattern. It's like a seizure, right? A seizure is an electrical firing pattern that all of a sudden gets into such a weird rhythm. My words, certainly not neuroscience's words, but a rhythm or a pattern where now it can't function normally, and you truly, like in a moment of a seizure, you're not conscious. Like you're literally not a conscious being. You don't know what's happening. You probably have no memory of it. So I imagine it's something like that, where there's enough variable options and paths for the brain to make the necessary connections to create what I'll call the illusion of consciousness. And so because it could do it, let's say, 15,000 different ways, but now you're beginning to break down enough of those paths that it almost becomes more common for one of those 15,000 to be broken than for one of those 15,000 firing patterns to work. And so if you happen to be in, let's say now you're at a 70% pathway of this results in sort of a null consciousness, and then 30% of the time it's those lucid moments of, whoa, so for whatever butterfly effect reason, you fall into one of the patterns that works, but then you're going to fall back out. Look, that is a layman's answer, but...
Yeah. And no, it's cool. Like it's really interesting. And then the other issue is, there's probably not like one specific area. So if you could just knock out one area, I don't think there's ever going to be just one little area that you knock out and your consciousness is just there or not, because then you could just pinpoint it. So I mean, it's just then I suppose the follow-on question is, if you did know what it was, could you then put it into like an AI or whatever, or could you build a mechanical brain that has consciousness? And it probably is going to happen at some point.
Almost certainly. And here's the question, and this is why I guess I don't really care about consciousness. Like, is there a difference between it being real and being an illusion? No. So even if the AI is just emulating all of the firing patterns and behaviors of something that we consider conscious, like, is there a difference between that and what we're doing? No. So to me, we are machines, computers, however you want to think about it, but the parts happen to be biological. But that's it. Like, if you disassemble the parts, you disassemble the consciousness, the ability to act and interact. It goes away. You must know the story of Phineas Gage. Okay, so the thing that made me fall so deeply in love with neuroscience, right? So you've got this guy, he's working on the railroad. Everybody is like, Phineas Gage, such an affable guy. He's one of the managers on the railroad, just a great guy. Everybody likes working for him. And then he hits a tamping rod. For whatever reason, the charge goes funny, and it shoots a metal rod, like a 3-foot metal rod with like a diameter like that, up through his chin, out through his brain. He never loses consciousness, but loses a teacup, not tablespoon, teacup full of brain matter. And they're like, he's never the same. And his personality changes, becomes a dick, can't hold a job, like can't focus. So it's like, is he still Phineas Gage? Right? Like, his personality is fundamentally altered and forever in a flash, just like that. So understanding that and this was actually a big breakthrough for me from a personal development standpoint, understanding that I am a chemical processing plant and that I'm going to manifest emotions and feelings based on whatever chemicals are pumping, which then gave me the absolute obsession with going back to the very first thing you said, that this is all essentially, you didn't use the words, but the matrix, right? This is your brain is creating this reality that feels so very real, but it's not, it's a construct. So if I'm a chemical processing plant in the middle of a construct, my very sense of identity and what's happening around me is all in that construct based on a moment-to-moment neurochemical reaction. Can I learn and the answer ends up being through physiology, can I create a loop where just by holding a smile or laughing out loud that I can literally change the neurochemistry in my brain? So we've gone a long way from the initial question, but that I find very, very interesting. So we have one more question here from Mickey Jackson. How do you find your set point? Or is there even a way we could as the average person? So, all right, that'll bring us back to Ghrelin and all of that stuff. So how is that set point defined? Where does it come from?
That's it. I mean, that's the question. The hypothalamus has just set this, and it's at a level, probably genetics, epigenetics, there's a whole host of things.
Well, so define, because I think this is the future of medicine, is epigenetics. What are genetics and what are epigenetics?
So your genetics are effectively what you... So, I mean, in a really simple sense, I'm sure the Puritans will probably come after me for this, but in a really simple sense, your genetics are what are just naturally expressed. So, your DNA comes from your mom and dad. Some things are going to be expressed. There are lots of hidden things which are not expressed, okay? But epigenetics would be where, again, sorry for the Puritans, but basically you can force expression by something environmental. Okay, so probably the most easy to understand example is like schizophrenia. So you could have a kind of dominant gene for that somewhere, but it might never come out your entire life. But if you had, say, some sort of event, maybe in childhood or whatever, actually that gene can turn on, and then later down the line, that actually presents, even though you could have a twin with identical DNA and it never presents.
Have you heard about marijuana kicking off schizophrenia for somebody that's like predisposed to it?
Yeah.
So that's interesting. That's a really easy environmental factor to think about. Two identical twins. They both have this predisposition for schizophrenia. One, it never manifests because they don't smoke weed. And then the other, it manifests because they do smoke weed. And then let's say that your brother or your next door neighbor smokes weed all day, every day. And they never, they don't have a problem because they don't have a predisposition for that.
Yeah. Yeah, no, it's really interesting, but obviously it's depending on sort of the factors, and as you say, sort of you had someone who did or didn't, it can just trigger it. And actually we don't often realize sometimes that the potential trigger could have been back a long time ago, and then this manifests later in life. So I mean, there are epigenetic factors in weight gain. So the hypothalamus probably, or well, in fact definitely has set for what we would call a normal body weight, okay? The problem is we are then influencing that, and certainly some of that is going to be genetics and epigenetics. So, for example, if both of your parents are overweight, you are much more likely to have a set point that's going to be higher. But even that, even having, say, thin parents doesn't necessarily protect you against it.
Well, now you're getting into the really fascinating part about epigenetics, which is people are getting, and I've got to believe people can just feel this. We're getting fatter and fatter generationally by the minute. And when I was a kid, when you were a kid, the parents were always fatter than the kids, always. And all anybody ever talked about was, oh man, to be young again, to be skinny, oh, you're so lucky because you're a kid and enjoy it while it lasts, right? Enjoy it while it lasts. That was the dominant thing people would say. But now you're seeing kids that are significantly heavier than the parents. And it's what the fuck? So looking at what the epigenetic factors are going into that, whether it's what the mother was eating during gestation and what kind of triggers that had, maybe she used to be heavier and has lost the weight, or the dad used to be heavier. As some of this stuff is, oh God, what's it called? When it's passed on, when it reaches your, the egg or the semen, there's a name for traits that are passed on. There's a name. Sorry, I'm forgetting it. But there are certain traits that will pass down generation to generation. And they were doing tests, and it's something up to, at a minimum, 3 generations. One, the grandfather, something happens to him, a famine, whatever. And I think that's where this study, one of the manifestations of this concept anyway, was the people in the Netherlands during World War II. There was a famine because the Nazis were blocking food getting in. And so you got to see all the women that were pregnant during that famine period, what ended up happening to their kids. And it's so significant. It's 30 or 40% more likely to be obese than people that were born either before the famine or after the famine. That's nuts. Yeah. And then what happens to their kids, and does it exacerbate? So if they were born after the famine, and so now from an epigenetic standpoint, their genes are expressing for store fat, store fat, store fat, because you never know when you might eat again, right? That's the signal that the mother gets, which is then passed on to the child gestating. And then if they eat poorly and trigger some of these other epigenetic factors, which causes either the hypothalamus to get out of whack, get inflamed, whatever the case is that causes this, now you've got this double whammy of 2 epigenetic factors that aren't even related. In fact, they feel like exact opposites, but they have this magnification effect in terms of the storage of fat, which I find really, really interesting.
Yeah, I mean, the take-home message from that would be for parents to, when a woman's pregnant, really needs to think about her diet, because actually studies have been shown, and it actually does relate to the hypothalamus, that even at that stage it can affect the long-term outcome. And then the other thing is, when kids are kids, the diet has to be better. The problem is today's diet is just not fantastic, and then the knock-on effect is that your set point is pushed up. So as a kid, you're already fighting a losing battle. So no, it's absolutely. So to answer the question, how do you find your set point? Actually, if you didn't try to lose weight or you didn't try to gain weight and you just ate like a sort of normal diet, you will sit at your set point.
So really fast, just to bring it all around, because we have to wrap up here. So going back to the device, so give us the vision of Modius Health.
Yeah.
So not just the device, but what's the vision for Modius Health? And then we have one final question that I think you're uniquely qualified to answer. So I want to make sure we get to that.
Okay. So the whole point of this is, as I say, the hypothalamus has now got that lower limit for weight. So as you start to try and decrease your weight, so people feel they're a little, a few pounds too heavy. If you hit that lower limit that I'm talking about, then all of a sudden your hypothalamus kicks in to stop you losing weight. Okay. And that is extremely different. I mean, I don't want to say impossible, because it's not, but it is almost impossible for a lot of people to lose weight at that stage. I mean, they will try, they will plateau, the weight will go no further, and if they keep going, they'll eventually get there, but they're always going to fight against that for the rest of their lives, probably, or they'll give up. Okay, so that is the fundamental problem. So people say, it's just willpower, it's just, exercise more, diet less. Yes, that's correct. But if you do that, you're going to inevitably kickstart that mechanism to stop you losing fat. Okay, so the idea with Modius is the vestibular stimulation. The vestibular nuclei has a really strong relationship with the hypothalamus, much more than we realized. And actually, whenever you look back through the literature, there's about 50 years of evidence showing not just the link, but actually the fact that it links to a positive metabolic outcome. So stimulating the medial vestibular nucleus in the brainstem actually causes your body to adjust. Okay, it causes you to lose, basically metabolism shifts, okay? And then the consequence of that is your appetite goes down and you start to reduce your body fat, okay? So the idea behind Modius is we are stimulating that repeatedly. That's what you're wearing right now. It's stimulating the vestibular nerve, which connects eventually to the hypothalamus. But it's not just a connection, it's the connection that we know for a fact influences metabolism, okay? So the idea behind Modius then is for people who are trying to get over that plateau, to stop that mechanism kicking in, or to certainly try and make it less of a disadvantage, then we're stimulating that part of the hypothalamus. So effectively, that is it in a nutshell. So we're trying to make it easier for people to lose weight.
Yeah. So to use the device to adjust that set point.
Yeah, or to certainly make so as I say, once you start dieting, exercising, there's going to be a kickback. Your brain does not like that. It thinks you're getting too lean. We want to stop that kickback and allow you to push things down.
Right. So one thing that I think I really want you guys to know about these guys is, so their vision is Modius Health. So it's not just wear a device and all your problems go away. It's wear the device, eat right, exercise. They've got a whole lifestyle program around this. I know that you guys consider yourself to be in a discovery phase. So you did an Indiegogo account. Your target was $40,000, $50,000?
$50,000.
Okay, so $50,000. You hit that in 2 hours. You blew past it in 4, and then by the 24-hour mark, you were at $800,000. So there's clearly an appetite for people to try this. One thing that was important to me before I would get involved with the company, there had to be a money-back guarantee, and that I would never be asked to say something about the device or its effects and actually believe. I use it religiously. People will see me all the time in my Instagram feed wearing it while I'm doing whatever. I am very curious to see what impacts it's going to have. Right now, I will say for me, the jury's out. I think it's intriguing. I think there's a lot of data there, and we didn't get to talk about the fucking mice. The study of the mice that NASA did, where they lived in basically not with a device like this. It was accidental. They were trying to test the effects of gravity for the astronaut program. And so for like a year, these mice lived constantly in motion, spinning, 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 spinning. But their whole existence was in that. They played in their wheel, all of it, spinning, spinning, spinning. And all of them got shredded. And the first assumption was, well, it's because the gravity is doubled, and so they're just working harder. So they then destroyed the inner ear of the mice and said, well, if that's true, even without the inner ear, which is where you're tracking the motion, then they should still get lean. And they don't. So really, really intriguing data coming out. I want you guys to make up your own mind. So we are going to be giving one of these away. Use it, see what you think. What I love about you guys, you're not over-promising, right? So this is where we're at. They want to collect feedback. That's why you guys did the Indiegogo account. You'd already raised the money. You didn't need to sell the units, but you did it to incentivize and then gave further discounts to incentivize people to give you the data. And the data is what you really care about. That was what intrigued me about him, the fact that Rama's involved. You've got other amazing people, including Dr. Drew on the board. It's just really interesting. And I think everybody right now is sort of holding their breath and saying, man, if this really works, then its implications are really, really exciting. So be super curious, whoever wins this, to let us know what you think. All right, the giveaway winner, in fact, now we know who won this. It's Marco Vendrame or Vendrame, one of the two. Congratulations, Marco. You and I will be vestibular stimulating together. So welcome to the club, my friend. All right. Jason, thank you so much, dude. I have really enjoy your company as a human being. I love these talks, and we're going to be going harder and harder on health here at Impact Theory, so we'll definitely have you back on. So thank you, my friend.